Okay, so we got a lot of questions about graphing during class today, and since I would love to fix all of my mess ups, since I don't think I explained it very well and I thought it was kind of confusing, we are going to try again by looking at the two examples on the bottom of page 6. So 3a and 3b, you are asked to find the inverse equation and state its domain and range. And so you'll notice that A is an exponential and B is a log. So this will give us a procedure for finding an inverse equation and finding domain and range for both an exponential and a log. And we will also address some of the oddities of the calculator when you're graphing logs. So take a look at 3A to start. Okay. So for this one, when I'm finding the inverse, I know that it's helpful to have x and y in the equation. So you want to change out that function notation. And then to find an inverse, we swap x and y. And now we're going to go through the process of actually freeing the y from the exponent, right? So isolating y, which means move all the other stuff to the other side, do opposite operations. So my first step is to add 2. X plus 2 equals e to the y plus 1. And then from here, since I'm seeing a base to a power, and I want to try to get the power out of the exponent, I'm going to take the log of both sides, but specifically because the base is e, I'm actually going to take the natural log of both sides. So it'll be ln of x plus 2 equals ln of e to the y plus 1. Now with this notation, it's sort of understood that you have this little subscript e here. You don't have to write it in. It doesn't need to be there. But the thing to remember is that if you want to get a log to cancel with an exponent, you need to have those matching bases. So ln and e cancel each other out, and we have ln of x plus 2 equals y plus 1. Last step, subtract 1 from both sides. Just trying to do your best to isolate y, and here we have it. This is the inverse function. Okay, so let's do this. Let's talk about what the domain and range would be for the original. And then we'll find the domain and range of the inverse. So to do this, I'm actually going to go to my graph. And so in y equals, how did that happen? Weird. In y equals, I am going to graph, let's see, e to the x plus 1 minus 2. Okay, and I'll just take a look at this graph in a standard window. So here's our exponential function. So it's looking like I've got a horizontal asymptote appearing, and I think it's at -2. And if we double check our equation, that would make sense because there's that vertical shift. In addition, I can see that my x values continue towards infinity, and we could confirm that in the table. So if you hit second graph, you can look at your table of values, and we can check to make sure that our table of values is going to output a y for all of our x's. Now right now I have my delta x set at 0.01. I can change that if I do second window. I go to my table setup menu. I'm going to change my delta table back to 1. And then when I go to the table, now everything's going up by 1 unit. And what I'm seeing is that for all of these positive x values, I'm getting a corresponding y. And I can even go negative to double check as well. And I'm seeing all my negative x values are also outputting a y. So the domain for this function is all reals. It's the range that has restrictions. And so when we go back and look at the graph, remember you have a horizontal asymptote here. So my y values need to be greater than 2, but they're not going to equal 2. And I could also confirm that if I look at the table, because what we're seeing is that as we go negative, even though it looks like these y values are actually -2, they're not really. If you scroll over, it will give you the actual value of the y coordinate. It's just that this is so close to -2 and the column is so short that it truncates the value and it rounds it. But that's not actually a y coordinate of -2. It's -1.9999999, right? Really close to -2, but not quite getting there. And you could go even further, go to an even more negative x value, check out the corresponding y. It's not really -2. It's -1.9999999. All right, so that's the domain and range for the exponential graph that was given, and it has a horizontal asymptote at y equals -2, my bad, -2. Range -2, and asymptote -2. Okay. So when it comes to finding the domain and range of the inverse, right, the equation we found here, the domain and range, we're simply going to swap the domain and range from the original. So the domain of the log becomes x greater than -2, and the range becomes all reals. And the asymptote, even though they didn't ask you for it, we can still put it in. The asymptote is going to occur at x is -2, and that's going to be a vertical asymptote. So this one's a horizontal asymptote. This one's a vertical asymptote. So now what I'm going to do is go back to the graph, and I'm going to graph both of these simultaneously. So I'm going to put the ln of x plus 2 minus 1. So this is the graph of the inverse. I'm going to add it, and it's going to come up in red. So the thing to remember here, and I addressed this a little bit in class, but kind of did a bad job emphasizing it. The red log, or the red graph, is the ln of x plus 2 minus 1. And even though it makes it look like the graph just stops here, that's not actually the case. That's your calculator having a little bit of a freak out. It's going to keep going, all right? And what's going to happen is this graph is going to continue to trend downward towards -infinity, but there is a vertical asymptote at -2. So we're never actually going to get to x is -2. We're going to approach it, but never quite get there. And so that red graph is continuing downward towards infinity. And so you'll notice that our real numbers, or our range, is all reals because I have all y values from -infinity to +infinity actually on my red graph, even though it doesn't really look like it. And we could confirm that if we go to the table setup. If we start our table right around -2, and if we change the delta table to 0.001, if you take a look at the table, so what we want to do is actually look at our, looking at the red graph was the log, so looking at your y values. When x is something really, really close to -2, but not quite -2, looking at your corresponding y, it's around -8. So when x is close to -2, y is -8. And so if you look at the graph, that would actually be a point somewhere down here. So again, it's part of the table. It's technically part of the graph. It's just your calculator having a really difficult time graphing something that almost goes perfectly vertical. Okay, so let's move into the log. Okay, so now for the log, we're going to convert this to an exponential. Okay, so I'm going to swap x and y. And the goal is to isolate y. So I'm going to subtract 1 from both sides. And now right here, I've got the log all by itself. I'm trying to free this expression from the inside of the log. So I want to turn this into an exponential. And I'm going to take both sides of this equation and put in base 2. When I do that, these are going to cancel each other out. So I have 2 to the x minus 1 equals y plus 4. Last step, subtract y from both, or subtract 4 from both sides. So this is our inverse equation. Okay, so let's just go graph the original and find the domain and range of the original. We can also find the asymptote for it as well. So the original, we go back to y equals, that's log base 2. So I actually want to do the change of base. Log base 2 of x plus 4 plus 1. So if I just graph this, again, because I'm graphing a log, it makes it look like it just sort of stops there, but that's not actually the case, all right? So I have a vertical asymptote occurring at -4, all right? And you can kind of see that here. Vertical asymptote occurring at -4. This graph is going to continue downwards towards infinity. It's just really hard to see it. So for our domain is going to be x values greater than -4. But your range is actually going to be all real numbers. Sorry, move this over. So because technically the graph is actually going downwards here towards -infinity, getting closer and closer to that horizontal asymptote without getting there. Okay, and vertical asymptote at x equals -4. Vertical asymptote on that graph. Okay, so when it comes to finding domain, range, and asymptote for the inverse, we're just going to switch the domain and range from the original. So the domain and the range of the original, let's see, the domain was x is greater than -4, so the range will be y is greater than -4. And the domain for the exponential will be all reals. This will have a horizontal asymptote at y equals -4. So let's confirm that. Let's go look at the graph. If we put in, let's see, it's 2 to the x minus 1 minus 4, and we'll take a look at the red graph now. What we're seeing is a horizontal asymptote at -4, all x values from -infinity to +infinity, so the domain is all reals, but the range is -4 or greater, and that's exactly what we wrote here. All right, so I think the moral of the story here is that when you're graphing a log, like the thing in blue, just remember that even though your calculator makes it look like the graph stops, that's actually not the case. It's going to continue downward in this direction so that we actually have appropriate symmetry of the exponential and the logarithm. I hope this was helpful. I'm really sorry about the mess up today, guys. Let me know if you have more questions.